Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman Al-Hakim Ramdan. I am a student of UiTM Shah Alam. Today, I'm going to answer a question of thermodynamics. Alright, as we can see here, the question 11 thermodynamics. Air is contained in a piston cylinder device at 60 kPa and 927 degrees Celsius and occupy a volume of 0.8 meter cubic. The air undergoes an isothermal process until the pressure is reduced to 300 kPa. The piston is now fixed in place and not allowed to move while a heat transfer process takes place until the air reaches 27 degrees Celsius. Sketch the system showing the energies crossing of for the boundary and the PV diagram for the combined process. For the combined process, determine the net amount of heat transfer and its direction. Alright. First, as we can see here, we need to sketch the PV diagram for this question. Okay. So to answer the question, first we need to know what is the first work that happened in to the air. So we can see here it's on 60 km per pressure and reduced to 300 kPa. So it undergoes to isothermal process. So it will go down here from 60 kPa to 300 kPa. After that, the volume is not changed, but the pressure and the temperature is changed. So we can see here it undergoes isobaric process like that. That is for the question A. Alright, for B, we need to calculate the net amount of heat transfer. Alright, for first, at state 1, it's on 60 kilopascal, 100 kilopascal, and it's 927 degrees Celsius, and it has volume of 0.8 meters square. From the given data, we can use it to find the mass of the air that involved in this process. We can use PV MRT. R, we use the air R, that is 0.287, and the temperature is, we must plus with 273 for to change it into Kelvin. so it will become 1 to 0 and get (1.394 kilograms for the mass of the air. And then at the state 2, on state 1 to state 2, the process, the air is undergoes isothermal process. So we need to use the equation from the isothermal process to find the volume on V2. Use B1. We fill in up the and get the V2 is 1.6 meter cube. Alright, now we already have the V2 for the state 2 in the air in the process. Alright, we already get the mass, the pressure 1, and volume 1, and pressure 2 and the volume 2. So we can use the isothermal process equation to find the boundary work boundary for the process. So V1 we can get 303 kilojoule for the isothermal process. Alright, after we get the work boundary for the isothermal process, we now need to find the internal energy in the second to the third state using because the process is when under to an isobaric process, we use internal energy mass CV, because the volume is constant on this process, and T2 minus T1 mass for CV is for CV at air, that is 0.718. Temperature is minus 1. Kilopascal. Alright, and then calculate we get negative 0.1 kilogram. Okay, after we get the energy, we can get the heat we can calculate the heat transfer to the system. The formula is Q we took back the 333 kilojoule plus minus negative 90.1 kilojoule and get negative 568 kilojoule. Okay, for this process, the energy is negative because the energy is used to the system, in the system. So that means energy is used to make the process happen. That's all from me. Thank you.